So you've seen the headlines, right? The crazy art, the big numbers. But have you ever stopped to think what an NFT really is? I mean, under the hood. It turns out, behind every single one, there's this really elegant, super powerful blueprint. And today, we're going to take it apart. We're deconstructing the ERC 721 standard. Yeah, it's so much more than just a JPEG. Think of it like a digital deed. It's this verifiable proof of ownership, all locked up in a smart contract. And that's the real question we're asking today, isn't it? What is actually in that blueprint? All right, let's get into it. Okay, so here's the game plan. First, we'll look at how this whole idea of digital uniqueness even started. Then, we'll get technical and peek inside the standard itself. We'll talk about the NFT's digital soul, its metadata. Then, we'll cover how it's evolved to be more efficient, and we'll wrap up with the really important stuff, security, and a look at what's coming next. All right, section 1. So our story here, it doesn't actually start with a solution. It starts with a problem. A big problem that was, funnily enough, brought to light by this super quirky pixel art project. Okay, so back in 2017, CryptoPunks hit the scene. But here's the crazy part. They were built on the ERC20 standard. Now, ERC20 was made for fungible tokens, stuff like digital coins, where every single one is the same. They were basically trying to use dollar bills to represent unique one-of-a-kind paintings. It just didn't fit, right? But what it did do was perfectly highlight the need for something better. And that directly led to the proposal for EIP 721. A year later, in 2018, it was finalized, and boom, we officially had the non-fungible token and the very foundation for the entire NFT world as we know it. Okay, so now that we know why it was created, let's get into the nitty-gritty. What are the core functions that actually make an NFT contract tick? And maybe more importantly, what are the big trade-offs that creators have to think about? All right, at the very, very heart of it all is one simple function, owner of. The best way to think about it, it's like a digital land registry. It's dead simple. You ask it, hey, who owns token number 123? And it gives you back one single undeniable answer, the owner's wallet address. Seriously, everything else is built on top of this one idea. Now, owning something is great, but you've got to be able to sell it or give it away, right? That's where safe transfer from comes in. It's the standard, secure way to do it. Think of it as a permission slip, but a really smart one. It has this crucial safety check built right in. Before it sends your NFT to another smart contract, it first asks, hey, are you actually equipped to handle this? That one little question prevents a ton of NFTs from being accidentally burned, just sent into a digital black hole, gone for good. Okay, this is one of the most brilliant parts of the whole design. ERC 721 is modular. It's not this rigid, one-size-fits-all thing. It's more like a set of building blocks. And what this does is it forces creators to make a really important choice. A trade-off, really, between packing in more features versus keeping those transaction costs, the gas fees, as low as possible for their community. And you can see that trade-off really clearly right here. You've got the core interface, which is super basic and cheap. It just does ownership and transfers. That's it. Then you have the metadata extension. Pretty much every project uses this one because it's what gives the NFT its actual identity. The name, the picture. But then you have the enumerable extension. This thing adds some really powerful features for discovering tokens on-chain, but whoa, look at that gas cost. It's so high because every single time something happens, it has to write a bunch of extra data to the blockchain. That gets expensive, fast. So wait a minute. If the main contract is really just a glorified spreadsheet tracking who owns what, where does the art come from? The image, the name, all the different traits. Well, that brings us to what I like to call the NFT's digital soul. Let's talk about metadata. The magic all happens with a function called token URI. And let me just say this again because it's a super common misconception. The art is not stored on the blockchain. No way. That would be insanely expensive. Instead, the contract just stores a simple pointer. That's it. It's just a web link that points to a little file, a JSON file, that lives somewhere else. And that's where all the good stuff is. So next time you pull up your NFT collection on OpenSea or in your wallet, here's what's actually happening in the background. First, the app calls token URI on the smart contract. The contract spits back a link. The app then follows that link, usually to a decentralized network like IPFS, and grabs a small JSON text file. And finally, that little file tells the app, okay, here's the link to the image, and here's the list of all its traits. And that's how it all gets displayed to you. But here's the catch. Where that little JSON file lives, that's a massive deal. A project can store it on a regular centralized server, like AWS. It's easy. It's cheap.
But it also means the creators have total control. They can change the art, tweak the traits, or even delete it entirely. Poof! On the other hand, if they store it on a decentralized network like IPFS, it becomes censorship-resistant and basically permanent. That's the choice that really lives up to the whole promise of blockchain, right?
And this is the key takeaway, really. The real permanence, the long-term value of your NFT. It's not guaranteed by the smart contract alone. Not at all. It is critically dependent on a decision that's made completely outside the contract, where to store that metadata. It's a huge detail that, honestly, most people overlook.
So what happens when something gets wildly popular? Well, you start to see its limitations. As NFTs just exploded, the cracks in ERC 721 started to show, especially when it came to cost. It just wasn't efficient at a massive scale. And that, naturally, led to evolution. New standards started popping up, all designed to solve this efficiency problem.
And that brings us to things like ERC 1155. See, while ERC 721 is perfect for a single collection of unique items, ERC 1155 is a whole different beast. It's a multi-token standard. The best analogy is a video game. A single ERC 1155 contract can manage your one-of-a-kind legendary sword, and your stack of 10,000 gold coins, and your 50 health potions, all in one place. And its killer feature? Batch transfers. You can send a whole bunch of different items to someone else in one single, super efficient transaction. That's a game changer for gas fees. So you start to see this pattern, right? Each standard is like a specific tool for a specific job. ERC 721, perfect for that one-of-one digital art piece. ERC 1155, amazing for gaming and complex ecosystems. And then you get something like ERC 721A. The team behind Azuki built this specifically for big PFP drops. Its whole purpose is to make batch minting ridiculously cheap. Now there's a trade-off, of course. The very first time someone transfers one of those freshly minted NFTs, the gas cost is a bit higher. It's a really clever way of shifting the cost away from the initial mint and onto the first secondary sale.
Okay, last section. Look, having a solid blueprint is fantastic, but if you build your house on that blueprint with shoddy materials, it's all going to come tumbling down. Security is everything. The standard is a great starting point, but how you actually implement it, that's what really counts. And here's the thing, even with a battle-tested standard like ERC 721, stuff goes wrong all the time. But the vulnerabilities are almost never in the standard itself. They're in the custom code that developers write on top of it. Simple mistakes like forgetting to put an admin-only lock on the mint function, or introducing classic bugs like reentrancy. We even see exploits in the logic for those gasless minting systems. The foundation is solid, but the construction can be sloppy. This case study from a Fireblocks audit is a perfect real-world example. Check this out. They found a high-severity bug, a huge one. It let anyone bypass the transfer restrictions. And why? Because the developers put the security check on one transfer function, but completely forgot to add it to the other one, safe transfer from. Oops. They also found another bug where a special burner role could destroy not just their own tokens, but anybody's tokens in the collection. It just goes to show you, security is all about sweating the small stuff. Look, there's no doubt ERC 721 has been a revolution. It literally created an industry, but it's not the final chapter. So what's next? Where does this idea of digital ownership go from here? Well, the future seems to be all about making NFTs more alive, more dynamic. There are new proposals being kicked around, like EIP 7160, that are designed to let a single NFT have multiple metadata links. Just think about that for a second. You could have a piece of art that literally changes and evolves over time, or an NFT that shows one image on your phone, but a completely different high-res version on a big TV screen. The original blueprint gave us these amazing static digital objects. This next wave, well, it's about giving them life. And the real question is, what are we going to build with that?